thoracic cage, the sagittal section, or you can say parasagittal section, through the thoracic cage to show you the various parts present or various structures present in the thoracic cavity. And this you can see that this is the middle structure, the middle mediastinum. Anterior to it is anterior mediastinum. Posterior to it is posterior mediastinum. Middle mediastinum is basically this region which is enclosed by pericardium, heart, and some parts of roots of great vessels. Above this, above the level of middle mediastinum, that is the plane passing through sternal angle to disc between fourth and fifth thoracic vertebra to the level of the thoracic inlet is the superior mediastinum. So, this aorta, which is the largest artery in the body, will commence from the left ventricle. Left ventricle is located within the middle mediastinum, within the heart. It is one of the chambers of the heart, and then it has to come out of it to supply the blood, oxygenated blood to the entire body. That means it's not going to lie only within this pericardial sac or within the middle mediastinum. It arises from left ventricle, that is within the middle mediastinum. Then it ascends and goes to the superior mediastinum, where it's forming the arch of aorta. Arch of aorta in the superior mediastinum which you saw. And this arch of aorta giving major vessels within the superior mediastinum, that is the brachiocephalic trunk, the left common carotid, the left subcarotid. Then again you saw this aorta and the posterior mediastinum, which we call the descending thoracic aorta. And beyond the posterior mediastinum, it travels through an opening in the diaphragm at the level of 12th thoracic vertebra to go to the abdomen, so that it can give blood supply to the abdomen and lower limb as well. So based on this, what are the major parts of the aorta? A part lying within the pericardial sac, emerging from the left ventricle, lying within the middle mediastinum is ascending aorta. A part lying in the superior mediastinum, it starts in the superior mediastinum at the level of the disc between T4 and T5 at the level of sternal angle and ends at this level. This is the arch of aorta, which is lying behind the lower half of manubrium sternum. Okay, beyond the level of disc between T4 and T5 is continuing as descending aorta with its two subparts, descending thoracic aorta and abdominal aorta. Descending thoracic aorta is lying from the level of the disc between T4 and T5 in the posterior mediastinum. Then it goes through the opening in the diaphragm to the abdomen at the level of 12th thoracic vertebra. Beyond that, this part of aorta, we call it as abdominal aorta, which we'll study when we'll study the abdomen. Today we are going to discuss about the ascending aorta, arch of aorta, and the descending thoracic aorta. So you can see that the thoracic part of the aorta is lying in the three parts of mediastinum: middle mediastinum, superior mediastinum with arch of aorta, and the posterior mediastinum containing the descending thoracic aorta. Let's put these one by one. Ascending aorta. This is a ventral view of the heart, the sternocostal surface with pericardium intact. And this, you can see that the ascending aorta is contained within the pericardial sac and is covered by a visceral layer of serous pericardium. you remember, we had discussed that the pericardium has a fibrous layer and serous layer. The serous layer had two parts, the parietal and the visceral. Parietal was attached to the inner aspect of fibrous pericardium, and the visceral layer of serous pericardium was intimately associated with the substance of the heart and the roots of great vessels that includes the palmate trunk ascending aorta. So, there is a common sheath of this visceral layer of serous pericardium which is covering this portion of the heart aorta emerging from the left ventricle, which we call the visceral layer of serous pericardium. The ascending aorta is approximately 5 centimeters long. It begins from the left ventricle, from the infundibulum of the left ventricle at its base, at the level of the lower border of the left third costal cartilage. Left third costal cartilage. Then it ascends obliquely, curving forwards and to the right. See, this is emerging from the left side and it's going obliquely, curving forwards and towards the right. On the right side is this right atrium and superior vena cava draining into it. So you can see that it's going towards the right. Then behind the sternum, since it has gone obliquely, it's at the level of the right second costal cartilage. So right second costal cartilage is the level of fourth thoracic vertebra. That is just between T4 and T5. So beyond this, this is going to continue as arch of aorta. At its origin, from the left ventricle, close to the aortic annulus, the sectional profile is very big and not simply circular. Why? Because 3 cusps, hemispherical cusps of the valve, aortic valve are present over there, which are called as sinuses of Valsalva, from which when the blood is pumping from the left ventricle to the aorta, it reaches the ascending aorta, and when the ventricle relaxes, that is not in the contraction phase, the blood does not come back into the left ventricle, but it gets lodges in these aortic sinuses so that the aortic valve is closed. The 2 coronary arteries are the branches of ascending aorta, the right coronary and the left coronary artery from this aortic sinuses. Now, beyond the level of the right second costal cartilage, that is at the level of disc between the T4 and T5 thoracic vertebra, or at the level of sternal angle, this ascending aorta now is named as arch of aorta. It continues as arch of aorta, which arches over the root of the left lung. It connects the arch, connects the ascending aorta as well as the descending aorta, because arch of aorta is beginning at the level of T4, ending at the level of T4, that is at the level of sternal angle, and is lying posterior to the lower half of manubrium sternum. So, arch of aorta is entirely located behind the lower half of manubrium sternum in the superior mediastinum. Ascending aorta was located in the middle mediastinum. So, it's a continuation of the ascending aorta behind the upper border of right second costochondral junction, where the ascending aorta is continuing as arch of aorta. So, from the upper border of the right costochondral junction, it arches upwards, backwards, and to the left. Anterior to the trachea. It's again oblique. It's not simple arch going from right to left. It's arching upwards and backwards. Ascending aorta was coming from left ventricle and coming forwards, anteriorly. This is going posteriorly. That is, it is arching not only upwards, it's completely placed, but backwards and goes towards the left. Anterior to the trachea. Over here, this arch passes over the root of the left lung on the left side of trachea. Then it turns downwards to reach again the left second costochondral junction, that is the lower part of the T4 vertebra, or at the level of sternal angle, or at the level of disc between T4 and T5. So, this arch of aorta is at the level of disc between T4 and T5, begins here, ends here. Ascending aorta ends here, descending aorta begins here. This arch rises till the middle half of sternum and then again descends. So it terminates at the second left costochondral junction. So continue as the descending aorta. What are going to be the relations of the arch of aorta? The superior relations of the arch of aorta will be obviously the branches of arch of aorta. That is, this is the arch of aorta. So superior relations are going to be its branches. The brachiocephalic trunk, which ultimately divides into right common carotid and right subclavian arteries. The left common carotid artery and left subclavian artery. So three constant branches of the arch of aorta: the brachiocephalic trunk, the left common carotid, left subclavian. Apart from that, this arch of aorta is crossed in front by the left brachiocephalic vein, because the right brachiocephalic vein and left brachiocephalic veins join to form the superior vena cava, which is present in relation to the right side of the arch of aorta. So, since right side of the body is the venous side, so left brachiocephalic vein has to come to the right side obliquely to join with its right counterpart, that is the right brachiocephalic vein, to form the superior vena cava. Apart from that, there is crossing of left phrenic and the left vagus nerve, which can be seen between the left common carotid and left subclavian arteries. So this is the left common carotid, there is the left subclavian. So you can see that the left vagus and the left phrenic nerve are also seen. If you remember the mediastinal surface of the left trunk, over here you saw the crossing of the left vagus and the left phrenic nerve. So what are going to be the posterior relations of the arch of aorta? The arch of aorta, which has been cut to show its posterior relations. Arch of aorta from right side is going backwards and to the left. So the relations posteriorly are going to be on the right side. So now on the right side of the trachea, the right side of the arch of aorta are going to be trachea, esophagus, then the tracheoesophageal tube, the left recurrent laryngeal. Now this is curved towards the left, so that's why left recurrent laryngeal nerve, the thoracic duct, and along with that some tracheoesophageal lymph nodes, the deep cardiac plexus, and further posteriorly the vertebral column. So vertebral column is now on the right side. The aorta has come towards the left. So vertebral column, the bodies of the vertebra are going to be more towards the right now. going to the anterior relations of the arch of aorta. Anterior relations, because again obliquely, so anteriorly to the and to the left, they are going to be left phrenic, left vagus, some part of the sympathetic trunk, some left superior intercostal vein, left lung, left pleura. So anteriorly, if you remember the mediastinal surface of the left lung, you view the arch of aorta around the root of the lung. So left lung, left pleura with left superior intercostal vein. This picture you had drawn in relation to the mediastinal surface of the left lung. Same. Inferiorly, arch of aorta, you see the pulmonary trunk arising from the right ventricle of the heart, and it divides into right and left pulmonary arteries. And this was obscuring, this presence of pulmonary trunk was obscuring the presence of aorta anteriorly, because this is coming from the posterior side. So that's why you can see in relation to the heart, the ascending aorta arising from the left ventricle. So inferiorly, this is going to be the pulmonary trunk bifurcating into right and left pulmonary arteries. Then again, the left recurrent laryngeal nerve, left bronchus, because the trachea also divides into right and left principal bronchi at the level of T4. So it has already divided trachea. So relation inferiorly is going to be left bronchus, because no aorta has gone towards the left. And along with that, the superficial cardiac plexus nerve, which is supplying the. There's the right lung, there's the left lung, there's the coronal section through the lungs to show you the relations of the aorta. There's the arch of the aorta, and this you can see these are the relations going to be towards the mediastinal surface of the left lung. So these are going to form the inferior relations of the arch of aorta, and that includes the bifurcation of pulmonary trunk and the left bronchus, left principal bronchus. Now, what are going to be the branches of arch of aorta? The major branches of the arch of aorta, or the constant branches, are three in number. The brachiocephalic artery, the left common carotid going to the head and neck, the left subclavian with seam continuing as axillary artery and ultimately supplying the upper lip, and before that left subclavian also gave some branches in the neck region. The brachiocephalic artery divided into right common carotid and the right subclavian artery. So three branches of arch of aorta: brachiocephalic artery, left common carotid, left subclavian. Sometimes, not very frequently, there might be an extra artery to the thyroid gland, which we call the arteria thyroidea, which may arise directly from the arch of aorta and goes vertically towards the thyroid gland. And sometimes left vertical artery. Why left vertical artery? Obviously, arch of aorta is going towards the left side. These are the three branches coming from the arch of aorta: the brachiocephalic trunk, the left common carotid, and left subclavian. Out of this, the brachiocephalic artery or the brachiocephalic trunk and the left common carotid arteries, they wind around the trachea before they further with this branches. Applied as well. Whenever we see plain diagram of the chest, that is chest X-ray, PA view plane, we will notice the two, on the two sides in the plain X-ray chest, the radiolucent areas of the two lungs. And in the middle portion, you will see a whitish radio-opaque shadow of the mediastinum. In that radio-opaque shadow, obviously it's going to be pericardium enclosing the heart and the great vessels. So in that, you will notice a convex bulge on the left side of sternal angle. This is the PA view of the chest, radiograph of the chest. And this, you can see that these are the two clavicles, the right clavicle, the left clavicle. Then you can see the bodies of the vertebra, and you can see small in between the bodies of the vertebra, the regions of the intervertebral disc. Then you can see the domes of the diaphragm, right dome of the diaphragm, the left dome of the diaphragm. This is the scapular margin. This is going to be the lateral border of scapula. This medial border is here. Lateral border of scapula and medial border of scapula over here. And you can see over here head of humerus and all. So in this radiograph of the chest, you can see that this lungs appearing black in color because of the air in them, right? Then you can see certain markings in these. These are the bronchial vessels, the bronchial markings. Then in the middle, you will see that the lungs are not radiolucent. Over here, you will see a radio-opaque shadow. That is the mediastinum. Heart, solid structure, so much muscular tissue, vessels present over here. So what you can notice in this X-ray is, this is going to be the left border of the heart. This is going to be the right border of the heart. This is going to be the inferior border of the heart, right? This is the apex. Apex of the heart on the left, fifth intercostal space, just medial to mid-clavicular line, or 9 centimeters from the midline of the sternum. Then along the left border, if you go superior, where this mediastinal shadow begins, you can see a bulge. This bulge. This bulge is due to the arch of aorta, which we call the aortic knuckle. Below this, one more bulge, but not so prominent, is visible. That is due to the pulmonary trunk. Okay, so this is the aortic knuckle. On the opposite side, you can see a vertical structure entering into the heart, that is superior vena cava, opening into the right atrium. So right border of the heart is almost completely formed by the right atrium. So in a plain diagram of the chest, you can see a convex bulge on the left side of sternal angle, and which is due to the arch of aorta, and this we call aortic knuckle. Then another aspect is aortic aneurysm, that is the localized dilatation of aorta, which can occur due to the syphilis or due to some degenerative changes in the aorta. Another anomaly in relation to the aorta is congenital stenosis or the atresia of the arch of aorta distal to the left subclavian artery. Sometimes you have already done the development of CVS, so you've seen about read about the correctation of the aorta. That is congenital stenosis of the aorta distal to the region of left subclavian artery. This is the anterior view of the chest. In this, you can see that this is the outline of the manubrium sternum. This is the body of the sternum. This is the xiphoid process. These are the two clavicles. The first costal cartilage, the second costal cartilage at the level of the sternal angle of Lewis. So you can see that the ascending aorta beginning at the level of third costal cartilage on the left side and ending up at the level of the second costal cartilage on the right side. From here, at the level of second costal cartilage, the arch of aorta begins and ends, it goes upwards, backwards, and to the left, and then descends, ends at the level of second costal cartilage only. So, right second costal cartilage to left second second coastal cartilage. Behind the upper half, behind the lower half of the sternum is the arch of aorta, and that is in the midpoint of the sternum. And beyond this, behind the upper half of the sternum and the superior mediastinum are the branches of the arch. So when you do the sections at this level, at the level of the T4, there was arch present. That is at the level of the T3, ascending and the descending aorta present. At the level of T5, ascending and the descending aorta present. And at the level of third thoracic vertebra, that is higher levels, you will find the branches of the arch. Now, the arch of aorta continues as descending thoracic aorta at the level of left second coastal cartilage. That is just between T4 and T5. And the descending thoracic aorta is lying in the posterior mediastinum. It begins as a continuation of the arch of aorta on the left side of the lower border of the body of the T4 vertebra, just opposite the sternal angle of Loeys. This descending thoracic aorta runs downwards from the posterior mediastinum, inclining forwards and medially to reach the anterior surface of vertebral column. Arch of aorta had vertebral column to its right side because it had gone towards the left. Now, from left side, the descending thoracic aorta is inclining forwards and medially so that it lies on the anterior aspect of the vertebral column, that is from T5 vertebra, T6 vertebra onwards, is going to be anterior to the vertebral column. At the level of 12th thoracic vertebra, it passes behind the diaphragm to the aortic opening present in the diaphragm at the level of 12th thoracic vertebra in the midline, and it becomes continuous with the abdominal aorta, that is now close to the abdomen, and so it's called the abdominal aorta. This was the ascending aorta, giving branches, that is coronary vessels, arch, giving the brachiocephalic, left common carotid, left subclavian, then arch continuing as descending thoracic aorta, which is going to give some branches, and this descending thoracic aorta at the level of T4 will go to the abdomen and become abdominal aorta and will give branches which will study. These are going to be major branches of this descending thoracic aorta. It gives the posterior intercostal arteries and the lower 9 intercostal spaces, and then the subcostal arteries which run along the lower border of the 12th rib to enter the abdominal wall. We have seen the blood supply to the thoracic wall, so you know there are posterior intercostal arteries giving on either side from the descending thoracic aorta and the lower 9 intercostal spaces, and below the 12th rib, the subcostal arteries. What happened to the upper two spaces? Upper two intercostal spaces, posterior intercostal arteries. Think about it, from where they are coming. They have to come from some branch above, that is from the thyrocervical tract, that is from the subclavian. Then it gives certain pericardial branches, certain esophageal branches, pericardial branches to the pericardium. Heart is supplied by coronary arteries, which are branches of ascending aorta. Then esophageal branches, then left bronchial artery. What happened to the right bronchial artery? So let's see in detail about these branches. The pericardial branches will enter the posterior aspect of the pericardial sac and will supply the pericardium. Two left bronchial arteries come from thoracic. As far as the right bronchial artery is concerned, that is one only, and this is given from the third posterior intercostal artery or from the left upper bronchial artery. So, right bronchial artery is not coming directly from the descending aorta, but by the third posterior intercostal artery, which is again a branch of artery. Then it gives 4 to 5 esophageal branches, which will supply the thoracic part of the esophagus. Then it gives the mediastinal branches, which will supply other structures present in the mediastinum, whether lymphatic structures, lymph nodes, vessels, nerves, other connective tissue present in the mediastinum. Then it gives the posterior intercostal arteries, which are 9 pairs from the posterior part of the thoracic aorta, the lower 9 intercostal spaces. Upper 2 spaces are supplied by the supreme intercostal artery, which is a branch of costocervical tract. Then also, now it's going to continue as the abdominal aorta beyond the 12th thoracic vertebral level. So, after giving the subcostal artery, it also gives the blood supply to the superior surface of the diaphragm, which we call the superior phrenic artery. So, these are the branches of the descending thoracic aorta. The 9 pairs in the lower 9 intercostal spaces, posterior intercostal arteries, subcostal artery. Then, the upper 2 spaces by the supreme intercostal artery, branch of costocervical. It gives branches to the esophagus, it gives branches to the mediastinal structures, it gives two left bronchial arteries. Right bronchial artery is usually branched from the third posterior intercostal artery, that is indirectly through it. And then it supplies the pericardium. Now, another great vessel present along with the aorta we saw was superior vena cava. It's a venous structure carrying the venous blood from the upper half of the body to the right atrium. So it brings the blood from the upper part of the body into the right atrium. There are no valves. It's devoid of valves. We're seeing that the veins in the head and neck region had valves. The superior vena cava is one structure which does not have valves. It's very wide, 2 centimeter wide structure and almost 7 centimeters in length. It is formed posterior to the low border of the right first costal cartilage by union of right and left tracheocephalic veins. It descends vertically downwards behind the first and second right intercostal spaces, right side. Right side is the venous side. It has 2 parts. One part is outside the pericardium, one is within the pericardium. Outside the pericardium, it lies in the superior mediastinum. You must have seen the contents present in the superior mediastinum, superior vena cava. Then we discussed in the middle mediastinum also superior vena cava is present. So there is an intrapericardial component to it, in which this pierces the fibrous pericardium at the level of right second costal cartilage, and that part lies in the middle mediastinum, and then it comes into the right atrium. What are going to be the relations of superior vena cava? Whether it's present in the superior mediastinum or middle mediastinum, laterally they are going to be right side. It's going to be related to right lung, pleura, pericardiosphrenic vessels, phrenic nerve of the right side. And anteromedially, that is medial to it, and anteriorly is going to be ascending aorta. Difference is going to be in the superior mediastinum and the middle mediastinum posteriorly only. In the superior mediastinum, medial to it will lie trachea and the right vagus nerve, whereas in the middle mediastinum, it's going to be root of the nerve. What are we going to do? Tributaries of superior vena cava. It's going to be formed by the joining of the right and the left brachiocephalic veins. Then azygous vein enters into the superior vena cava just before it pierces the fibrous pericardium. Then within the pericardium, it's going to receive the pericardial veins and mediastinal veins. So, major tributaries of superior vena cava include the right and the left brachiocephalic vein, the azygous vein, the pericardial veins, and the mediastinal veins. This is the superior vena cava, which is formed by the joining of the right and the left brachiocephalic veins. Brachiocephalic veins are joined by joining of internal jugula with the subclavian. With the azygous vein draining into the superior vena cava, and apart from that, it receives mediastinal and the pericardial veins, and then this drains blood into the right atrium. This is one of the tributaries or the structures we said opening in the right atrium is superior vena cava. In this picture, you can see the superior vena cava formation by joining of the left brachiocephalic and right brachiocephalic vein. The brachiocephalic veins are formed by joining of the internal jugular vein with the subclavian vein on either side. That is left internal jugular vein with the left subclavian vein forms a left brachiocephalic vein. Right side, right subclavian with the right internal jugular forms the left brachiocephalic vein. Since right side is the venous side, so left brachiocephalic vein crosses this arch of rota anteriorly to join with the right to form the superior vein. What happens when there is superior vena cava obstruction? There is something called superior mediastinal syndrome. Sometimes in cancerous growth and all, there can be further growth, lymphatic tissue rising, so superior vena cava can get obstructed. Some other anomaly can obstruct the superior vena cava. So in that case, what happens is superior vena cava, which can be obstructed either above or below the opening of the azygous vein. So the blood is shunted through the different set of veins into the right atrium. If its superior vena cava obstruction is above the level of azygous vein, so venous blood from the upper part of the body is returned via the internal thoracic vein. From internal thoracic vein goes into anterior and the posterior intercostal veins. From anterior and posterior intercostal veins, the venous blood enters the azygous vein and then superior vena cava and then into the right atrium. So instead of internal jugular vein and subclavian vein, so venous blood comes via the internal thoracic vein, or there can be joining of the superior epigastric and the inferior epigastric veins, which will drain into the inferior vena cava, and inferior vena cava also brings the venous blood into the right atrium. What happens if below the entry of the azygous vein, the superior vena cava gets obstructed? So, in that case, the blood is returned via the superior and the inferior epigastric veins into the femoral veins, and femoral veins through femoral veins into the inferior vena cava and heart. Then sometimes it can also go through the thoracoepigastric veins, which connects the axillary vein with the great saphenous vein. This is the only vein connecting the upper limb and the lower limb, or above the umbilicus and the below the umbilicus, the venous structure, thoraco-epigastric vein, which has connection with the axillary vein, with the great saphenous vein, and through this into the inferior vena cava, and then reaches the heart. That's all for today. Thank you.